Okay, continuing with section 5.4, let's consider the product of some formulas. Namely, we had cosine of alpha times cosine of beta was 1/2 the sum of the cosines, namely cosine alpha plus beta plus cosine alpha minus beta. And what I'd like to do is eliminate the 1/2. So I'm going to multiply both sides of this equation through by 2 to get rid of that. So on the left, we'll now have twice cosine alpha. Cosine beta is equal to what's inside the bracketed remark, namely cosine alpha plus beta plus cosine alpha minus beta. Okay, so what I'm going to do is I'm going to do a substitution. I'm going to let u be alpha plus beta. So let me put that over here. You'll see why I'm doing this. And I'm going to let v be alpha minus beta. Okay, so I'm going to take the sum and difference of these guys. So on the left, I have u plus v. And what that yields is that the betas reduce. And I end up with twice alpha. Dividing by 2, I get that alpha is equal to the sum of u plus v all over 2. So u plus v all over 2. So similarly, on the right, if I take the difference, u minus v, that negates the right-hand side, so the alphas reduce, and I get 2 positive betas, so beta will be u minus v divided by 2, when I divide both sides by 2. Okay, so let's rewrite now 2 cosine alpha. Well, what is alpha? It's this u plus v all over 2. So u plus v divided by 2 is now alpha. Times cosine of beta. Well, what is beta now? It's u minus v divided by 2. And you might say, well, you just complicated things. Yes, on the left. But let's look what happens on the right. Actually, I don't like that parenthetical. Let me make that a bit better. So on the right now, I'll have cosine of alpha plus beta, which is just u, plus cosine of alpha minus beta, which is now just v. Okay. So let me go ahead and put a box around that. Okay, so let's do the same thing with sine alpha, sine beta. Okay, so we have sine alpha, sine beta, and that was analogous. Let's go back up and see. So sine alpha, sine beta was negative 1/2 cosine of the difference. Okay, so this is going to be negative 1/2 cosine of alpha plus beta minus cosine of alpha minus beta. So in this case, I'm going to multiply through by negative 2 to reduce, right? So what I end up with is negative 2 sine alpha sine beta is just going to be what's inside the bracketed remark, namely cosine alpha plus beta minus cosine alpha minus beta. And I will do the same substitutions. I'm going to let u be alpha plus beta. So u is alpha plus beta, whereas v will be alpha minus beta. And I'm going to take their sum and difference. So on the left, I take their sum, and on the right, I'll take their difference. Okay, so on the left, I have u plus v will be equal to, well, the betas reduce, so that's 2 alpha, which means that alpha will be u plus v all over 2. Similarly, here on the right, I have u minus v which means I'm going to negate the alpha minus beta, so the alphas reduce and I get 2 positive betas. So beta will be u minus v divided by 2. So plugging back into the formula, I have negative 2 sine of alpha. Well, what is alpha? It's this whole u plus v divided by 2 times sine of beta. Well, what was beta? It's this u minus v divided by 2. And that's going to be equal to cosine of alpha plus beta, which we know is u, minus cosine of alpha minus beta, which is v. So let's put a box around that. Now it's true, I could derive all 4 of these, but I think you get the idea, so I'm just going to list them. No, okay, why is this not working for me? It's supposed to autocorrect. This is supposed to be a box. Let's see. Nope, it just really doesn't want to do this for me. Ah, there we go. Okay. Okay, so this would be a sum and or difference. So what's going on? This would be the sum to product identities. Now remember, a difference is really a sum of negative numbers, so it is still under the same heading. So I'm going to say the sum to product identities. So the sum to product identities okay, spelling. Okay, so the first, cosine of u plus cosine of v, we found that to be 2 cosine of u plus v all over 2 times cosine of u minus v all over 2. Now cosine of u minus v, cosine of u minus cosine of v, we found to be negative 2 sine of u plus v all over 2 times sine of u minus v all over 2. And the 2 we did not derive are as follows, namely sine of u plus sine of v. I'm just going to give them to you. You can derive them the same way though. Will be 2 sine of the quantity u plus v all over 2 times cosine of the quantity u minus v all over 2. Whereas finally, sine of u minus sine of v will be 2 times cosine of the quantity u plus v all over 2 times sine of the quantity u minus v all over 2. Okay, so let's do an example, a couple examples with these. So for example, evaluate the following using the sum to product identities. So evaluate the following using the sum to product identities. Okay, so number 1, let's say we have sine of 5 pi over 12 plus sine of pi over 12. Okay, so I'm going to write this as sine of 5 pi over 12 plus, let's do sine of pi over 12. So this is the sum of 2 sines. So this would be the third identity. So I claim that that will be 2 times sine of the first argument plus the second argument all over 2 times cosine of the first argument minus the second argument all over 2, where the first argument is 5 pi over 12, and the second argument is pi over 12. Okay, so what does this give us? This gives us 2 sine of, so 5 plus 1 is 6 pi over 12, which I'm dividing by 2, times cosine of, so 5 minus 1 is 4 pi over 12, which I'm dividing by 2. Okay, so we get 2 sine of, well, let's see, 6 pi over 12 reduces to pi over 2 divided by 2 will be pi over 4. Remember, we just multiply the two denominators. 12 times 2 is 24, and 6 over 24 is 1/4. So similarly, over here, 4 over 12 reduces to pi over 3. 3 times 2, of course, is 6. Okay, so what do we have then? We have 2 times, well, sine of pi over 4 is root 2 over 2. And cosine of pi over 6 is going to be root 3 over 2. So one of the 2's reduces, but what we're left with is root 6 all over 2 when all is said and done. Okay, so let's do one more for good measure. Okay, so number 2, let's say we have 6 times cosine of, let's say, 19 pi over 12. 19 pi over 12 minus 6 times cosine of 13 pi over 12. Okay, so what do we have here? What color should I use? So this is 6 times cosine of 19 pi over 12 minus 6 times cosine of 13 pi over 12. Well, that's going to be factoring out the 6. What cosine of a difference? Well, that's negative 2 sine of the sum times sine of the difference. Okay, so this should be negative 2. What was it again? Sine of the sum and sine of the difference. So this is sine of first argument plus second argument all over 2. Sine of first argument minus second argument all over 2. Looks like I'm running out of space, so let me move this over. Make that a, oh boy, what just happened? What's going on? Okay, what's going on? Okay, where was I? Oh no, why did it undo it? Oh boy. Okay, let's move this over. And I want to erase this part. Where was I? Okay, so, ugh, verdammt, really? Come on, Apple. Please don't be. Come on, Apple. What is going on? What are you doing? Why? Okay. May Steve Jobs rot. Okay, where was I? Okay. Okay, so I think, therefore I am, where was I? Sine of the difference, but I need a bit more room. Okay, Gott sei Dank, endlich. Let's see if this works. Okay. Holy free holy, what was the first angle? It was 19 pi over 12. 19 pi over 12, to which I'm adding and or subtracting. Let me actually make these a bit more clear. Adding, subtracting. the second argument, which in our case is 13 pi over 12. 13 pi over 12. 13 pi over 12. Okay, good enough for government work, I suppose. Okay, so 6 times negative 2 is negative 12. And then what do we have? So this will be sine of 19 plus 13. Well, that'll be 32. So 32 pi over 12, which we're dividing by 2. And this is sine of 19 minus 13 is 6. So 6 pi over 12, which we're dividing by 2. Okay, so what does this give us? This gives us negative 12 times the quantity. Sine of, well, let's see. Technically, 2 times 12 is 24. So 32 over 24, those are both divisible by 8. Looks like 8 goes into 32 4 times and into 24 3 times. So 4 pi over 3 times sine of, so 6 over 12 reduces to 1 over 2. 2 times 2 is 4. So that's going to be pi over 4. Okay, so what do we get in the almost end? Let's see. I have negative 12 times the quantity. So sine of 4 pi over 3, which is in quadrant 3. I know it's negative. And it's a 60-degree reference angle. So sine will be negative root 3 over 2. Times, well, sine of pi over 4, well, that's in quadrant 1, and it's root 2 over 2. Okay, so I know my denominator would be 4, but 4 goes into 12 3 times, so this will be negative 3 times the quantity, negative root 6. So I end up with a positive 3 root 6 when all is said and done.